E vou mandar só uma foto aqui para... Pronto, desculpem, é só o tempo de eu mandar o link para os grupos dos orientadores, para não... porque houve uma mudança do dia e horário, meu receio é que para eles ainda achem que é terça-feira. Eu vou ter que sair da outra reunião, sinto muito. Boa tarde a todos. Então, agora já que estamos gravando, só para vocês saberem, esse ano as qualificações e as defesas dos alunos do 10 serão publicadas no YouTube do 10, que é um canal de YouTube institucional, e como a gente está se cadastrando no selo ODS Educação, eles precisam de evidências das ações. E temos 3 dissertações de mestrado sendo desenvolvidas, fora as que foram defendidas esse ano. Viu, Alisson? Eu quero botar o seu projeto, eu quero que você cadastre no selo, só temos essa semana. O seu é passível de patente, inclusive, Alisson. E Luka também o descarboniza com certeza, e talvez até mesmo esse projeto, se tiver resultados. A gente só pode colocar... Eita, professor Marmu está chegando, que bom, seja bem-vindo. Então, boa tarde a todos, vamos dar início, em breve, à qualificação de Luka, e essa qualificação vai ficar registrada no canal de YouTube do 10. Good afternoon, Mahmoud, Dr. Mahmoud, it's a pleasure to have you here with us. Thank you so much for coming. Today is a very special day for us at the group, Sustainable and Development Group. Alison is here, your student. And Mahmoud has been crucial in the last 2 years, advising. Right now, I think Luka is his third, master student advising process, and now he changed his university. So if you want to present yourself so everybody knows you, Mahmoud, feel free.
All right, thank you, everyone. I'm so glad to be here. Dr. Emily introduced me. So I'm Mahmoud Shakuri, professor in construction management. My background is concrete durability. Been doing research in this area for the past 10 years. And I'm looking forward to Luka's presentation.
All right.
Thank you so much, Mahmoud. And I'll take advantage and thank already the external advice. Ai, meu Deus, como é que diz? Banca de avaliação. Agora sou eu. Evaluation Committee.
Yes.
Yes, the external evaluator, which is Dr. Sergio Perez. He is a friend of ours and part of our research group for a long time, but he is also the coordinator of the combustion lab. And I'm going to let him present himself because he is a big resource of University of Pernambuco, and we are really honored to have him in the defense of Luka for his specialty. And after that, I'll present Vito, which is our internal professor at PEC. He is a new student, but he was a master's student from PEC. He did his PhD at Federal University, and he works on materials. So thank you so much, everyone, for coming. But I'll give the word to Professor Sergio and then Vito.
Okay, so good afternoon, everybody. I'm Sergio Perez. I'm a professor here at the University of Pernambuco, and I'm the head of the Fuel and Energy Laboratory. All right, it's not combustion. We do a lot of combustion, but it's a waste biofuels and biofuels production and use laboratory here at the University of Pernambuco. I am a mechanical engineer and also an industrial chemist. And I did my PhD at the University of Florida and I studied in England as well, where I did my master's. All right, so basically it's that, right? Okay, so it's a pleasure to meet you, Mahmoud.
All right, same here. Appreciate that.
Okay.
Thank you.
And Luka, you see,
Thank you.
yeah, you see, and eager to see your presentation and make some contribution to your work. All right?
Thank you, Sérgio. Eu passo a palavra para o Sr. Vitor. You can talk in Portuguese or English, but the English is better so Mahmoud can hear you, understand.
Okay, hi everyone. Hi, Professor Mahmoud. I'm an assistant professor at University of Pernambuco. I started as professor 2 years ago. Okay, I passed in a public selection. And now I'm also a professor under the graduate program of civil engineering. And I work with innovative construction materials, and such as transforming waste into pozzolans and alkali activated materials. And I work in this line of also transformate wastes and construction materials.
Great. It's a pleasure to be connected.
Yeah. O microfone está desligado, Emília.
Desculpa, estava dando uma palestra aqui, mas está certo. Thank you, everyone, for coming. And I would like also to acknowledge the presence of 4 members of the research group, Alison, Olga, Karen, and Jayce. Thank you for coming. And today you're practicing your English also. So, Luka, my dear, you have 20 to 30 minutes to make your presentation. All the members must have received your qualifiers, and just reminding everyone that the qualifiers in our program, welcome Maria Eugênia and Jalisson. Maria Eugênia is our co-advisor? No. It's not Maria Helena, no? Okay. So anyways, I just explaining that the qualifiers here in Universidade de Pernambuco is a step about 6 months before his defense, where the student has to show the capacity to organize his project and have the first results already analyzed and presented with the chronogram or with the timing for the next steps in order to defend by February. So the last time he has the final period he has to defend is December of 2026. That's when he should finish his dissertation. So he has 6 months from today to finish whatever is left over and have enough things done to be granted the title of masters in this case. Professora Maria Helena, his co-advisor also, Luka picked up 3 elements. You know, I work with sustainability, but he wanted to work with materials, so we asked Mahmoud to help, and we wanted to use life cycle analysis. So we went and found Maria Helena, Professora Maria Helena, who did her PhD in the Federal University of Pernambuco and work on that. So thank you, Maria Helena, for being here. If you want to say a word before Luka speaks, feel free to say something. Thank you for helping us also. Maria Helena está sem som. Não sei se você ouviu. A gente, se quiser se apresentar rapidamente para eles conhecerem a co-orientadora de Luka.
Oi, gente, boa tarde.
Boa tarde.
Infelizmente, eu não vou poder participar ativamente da apresentação, como eu tinha falado para a professora Emília, eu já tinha outro compromisso, mas eu vou estar atenta aqui aos comentários da banca para contribuir aí para o avanço, né, do trabalho de Luka. Já peço desculpas de antemão pela indisponibilidade.
Que é isso, professora, eu agradeço desde já, realmente nos recebeu lá no laboratório dela, abriu as portas e todo o seu conhecimento, a gente convidou ela para ajudar num projeto de descarbonize, que o professor Sérgio e o Luka fazem parte, e aí aproveitamos e chamamos ela para trabalhar como co-orientadora de Luka. Obrigada, viu, Maria Helena, querida? Então, pronto, vamos iniciar agora, né? Luka, querido, você tem exatamente de 20 a 30 minutos para fazer sua defesa. You can speak in English, and I pass the word to you. Start presenting, so I start counting the time after your presentation comes to the screen. You can start now.
Okay. Good afternoon, everyone. Thank you for the opportunity and for having everyone here to the presentation today. My name is Luka, and I'm here to present a proposal titled The Use of Expandable Polystyrene and Seashell as a Thermal Insulation Motor for Social Housing Units. My advisor, Professor Emilia Papani, my co-advisor, Professor Mahmoud Ashokero, and my co-advisor, too, Professor Maria Helene. Well, this proposal has been structured in the following way: the introduction, the objective, the systematic literature review, the methodology, the partial result, and the conclusion with respect to the proposal. Well, I'll say social housing has been a major issue all around the world based on the frequent housing deficiency which so many persons are really face around the world, and the likes of Sub-Saharan Africa, Sub-Saharan Africa having a population of about 199.5 million people living in slum areas. Likewise, in Latin America and the Caribbean, we have about 110 people living in slum houses. As a result, government all around the world, like here in Brazil, has created an initiative here in Brazil called the Minha Casa Minha Vida, which is my life and my home, as a form to alleviate the suffering of these people. And as estimated by the International Energy Agency, come 2035, the building industry is going to account for 45% of the total energy consumption being experienced. And the same vein, based on the mass construction of these houses, so many materials have been explored in order to construct these houses, contributing about 56.7% of the global carbon emission, which is a severe carbon emission, looking at it. In the same vein, these structures have come under immense scrutiny, one being due to the limited financial resources being put into the structure, due to the level of poor material quality, and also the level of infiltration, which these structures has also experienced in the form of thermal breaches. Thermal breaches also increasing the energy inefficiency of these structures, which is a major key aspect with respect to these structures. As a similar study was also reported here in Brazil by a study conducted by Silva. From the study, they discovered about 21.88% of the residents in the aggregate social housing project consume about 200 kilowatts of electricity. In the same vein, about 70% of these houses reported some severe structural pathologies and infiltration with respect to the infiltration of water and the likes in these structures. Along the line, so many researchers also demonstrated some level of materials to be used to better this situation. However, most of these materials have come under immense scrutiny based to the level of fossil fuel being used in the production of these materials. Why? The waste industry has really played a key part in bettering the situation of these houses. One of such ways to better one of such aspects is the waste industry. And this waste industry, we have the seashell industry, which in terms of the volume of production of the seashell, it amounts to 6 to 8 million tons, which is being produced annually, with just 25% of this waste being recycled in one way or the other. On the other hand, EPL, which is what we all know as a non-biodegradable waste, it was estimated to produce about 17.5 to 35 million tons of EPL alone within just 2020 alone. These materials are really played a key part in the waste management industry. However, the individual property of this material has been studied by so many literatures, and literatures have demonstrated that this material has some key aspects that bringing these three aspects together is going to produce a better efficient material to be used in these houses. Seashell, on the other hand, has a good acoustic property, a good resistance to fire, and also a good biodegradation properties. On the other hand, EPL, known for a reduced water capillary, a lightweight density material, and a good thermal insulation material, coupled with the aspect that it tends to resist crack. It has this crack resistant property. However, the combined use of both materials is still lacking in the literature through a life cycle assessment, which this proposal attempts to explore to fill in this gap with respect to these studies. Based on the objectives of this study, the objective of this study is to evaluate the feasibility of using this locally available waste, which is EPA and CSHARE, as a thermal isolation mortar and a thermal isolation mortar by studying its physical and mechanical property as well as its environmental impact in improving the energy efficiency of social housing projects. The specific objective of this research, one, is to evaluate the physical property of this research, of these mortars, including the different percentage of substitution, which is APL and CSHARE, as a spatial substitution of fine aggregates. The second objective, specific objective of this study, is to identify the potential impact of these materials, and its possible opportunity associated with the implementation of these materials for social housing projects. While the third specific objective of this research is to identify the ideal misproportion for this by considering its environmental effect, comparing the result with conventional insulation material through a life cycle assessment approach. While the fourth specific objective of this research is to evaluate the hydrothermal behavior of this material when being used in a typical social housing project. Based on this, the systematic literature review was being conducted by asking key critical questions. And one of these questions, what are the physical and mechanical properties of expanded polystyrene and CSHARE that make them more adequate to be used as insulation materials? What are the ideal misproportion of this?
Just a minute, Luka. Mehmet, go ahead. Mahmoud, sorry, Mahmoud.
He speaks very fast. It's so hard to follow. Can he speak a little bit slower?
Luka, please go slower, okay? Don't worry if it takes a little bit longer, but just go slower. It's really fast to follow. Thank you. Go ahead.
Okay, Professor. And the third specific objective, and the second specific objective, what is the ideal misproportion of these materials with respect to CSHARE and expandable polystyrene, which has a better thermal performance with respect to this? While the third objective of this is how does the thermal performance and environmental impact of expandable polystyrene and CSHARE used as thermal insulation material compared to traditional insulation materials? Based on this, three databases was being used with respect to research, one which is Web of Science, the second which is Science Direct, and the third which is Engineering Village. The selection criteria for this include articles published between 2015 to 2024, articles in open access with used, articles all in English, while the exclusion criteria involve articles that didn't adhere to the theme of discussion, articles that are duplicate were also excluded with respect to this. A total of 63 articles were being selected from literature synthesis.
Luka, please go slower, speak slower. Breathe in and breathe out twice before you start talking. Again, and then go slower. Don't worry about the time right now. Go ahead.
Okay, Professor. Okay, based on this, a total of 63 articles was selected. Based for the literature synthesis. Based on this, a descriptive statistic and inferential statistic was employed in analyzing the data from the literature. From the physical property, some key aspects of the physical property was being abstracted from the literature, which is the density and the water absorption, to check the correlation between these two properties. What is the relationship between density and water absorption with respect to expandable polystyrene being used as a thermal insulation mortar? From the linear regression analysis, an R-square was 0.50 to 0.93 was being obtained, which clearly shows a relationship between the two properties, which is density and water absorption. That yes, density clearly play a key part with respect to water absorption based on the linear regression analysis as utilized in respect to expandable polystyrene. On the same vein, particle size also matters with respect to thermal insulation mortar. The bigger the particle size, the more the circulation from the wall within water. So the larger the particle size, the more the circulation and the more the porosity with respect to humidity. While the smaller the particle size, the more the void spaces between these materials tend to be filled. Based on the smaller particle size tend to fill the void in between the materials. So many authors have really explored from different particle size, while the best particle size is from 0 to 3 millimeters, which is supposed to be used with respect to these materials to minimize the void between these materials. While on the aspect of CSHARE, study has clearly shown that vast majority of the properties of CSHARE is being composed of calcium carbonate. From the statistical analysis, an average of about 53.32% of what's being obtained, which clearly shows that vast majority of the chemical composition in CSHARE is calcium carbonate. With other materials having a least property. However, other authors also explored that using these materials based on the content of CSHARE, using this material as a cement replacement is not advisable. However, using this material as a substitute for aggregate is the best option. Based on using it as a cement, it has a low ozonic reaction and the level of silicate is very low with respect to this material. So it is advised to use these materials as an aggregate instead of associate cement replacement based on the analysis as shown here. Also, checking the correlation between density and thermal conductivity with respect to the both materials, which is seashell and expandable polystyrene. It is clearly seen that yes, density also plays a key part with respect to thermal conductivity of any of these materials. A linear correlation was achieved. An R square of 0.96 was obtained with respect to seashell, 0.96 to 0.986 was obtained with respect to the statistical analysis as shown, which clearly shows that yes, density clearly plays a key part with respect to thermal insulation materials when using seashell as an insulation materials. The same way, using the expandable polystyrene, an R square of about 0.97 to 0.98 was also obtained, which clearly shows that yes, density plays a key part using these both materials, using this material. So the higher the density, as the density tends to decrease, the thermal conductivity of this material also tends to decrease, and vice versa is the reverse is the case. While considering the level of substitution of both materials also matters with respect to the thermal conductivity of these materials. As the substitution level increases, the thermal conductivity of this material increases, and vice versa. The reverse is the case for both materials. So an R square of 0.98 was obtained, 0.98 to 0.99 was obtained on the aspect of seashell, while an R square of 0.74 and 1% was obtained on the aspect of EPL, which clearly shows that yes, the substitution level of this material play a key part with respect to attaining the desired thermal conductivity of each of these materials. On the aspect of comparing the thermal performance and environmental performance of these both materials, analysis was being done based on this to show how these materials behave with respect to traditional insulation materials. Comparing the both materials here, we have the EPL mortar, and the seashell mortar, comparing it with extruded polystyrene and expandable cork. It is clearly saying that yes, expandable cork has a higher thermal conductivity, which we need. What the research tends to achieve is to diminish the thermal conductivity of each of these materials. But expandable cork and extruded polystyrene has a higher thermal conductivity compared to the likes of seashell mortar, and EPS mortar. However, most of these materials here, most of the traditional insulation material has a thermal conductivity below that of expandable polystyrene and seashell. However, most of these materials are expensive, and also they have this water accessibility aspect whereby water tends to penetrate into these materials and they are difficult at times to find in the market. And the aspect of this is to recycle this material to achieve a similar property with respect to the traditional insulation materials. On the aspect of the embodied energy, utilizing an embodied energy of 1 meter squared on the production of all these materials, comparing these materials with the traditional insulation materials, it is clearly seen that here, seashell has a lower embodied energy compared to any other materials. However, studies have shown that the production stage of this material consumes a lot of energy. Even with a lot of energy, it still has a lower embodied energy compared to the rest materials. Compared to the likes of cork, which we all know is a natural material which has a higher embodied energy in the production process. While expandable polystyrene has a moderate embodied energy in terms of the production, it has a similar embodied energy in terms of the production with that of extruded polystyrene, as clearly seen here. On the aspect of the various impact category being utilized from the study, so many studies have also utilized various aspects we tried today in assessing the various impact category utilizing life cycle, but the vast majority of the study focused on the global warming potential, as a critical aspect in the impact category aspect, as clearly seen based on the different life cycle impact category method being utilized in the studies. The materials and methodology to be utilized in the proposal, one is to utilize the materials to be utilized as the normal Portland cement, which is here in Brazil called the CP2 the 32Z, the seashell, the Seguro shell, the expanded polystyrene, and the normal fine aggregate being obtained from the local market. While the laboratory to be used, I'm going to use the Poly Lab, the Structural Engineering Lab in the Federal University of Pernambuco, undergoing the following series of process: the production of the aggregates, the two aggregates, substitution level, the various tests, which is the hardening test and the fresh test, undergoing some morphology test, the life cycle assessment, and the test of simulation in the hydrothermal test. With respect to the preliminary phases of the material production is going to undergo a series of processes from the preliminary step with regards to the sourcing of the seashell from open landfills, the cleaning, the washing of the seashell, the oven drying of the seashell, the milling of the seashell, the sieving of the seashell, then producing the final aggregate with respect to the mortar, while that of the EPL, the same thing, the grinding of the EPL, the sourcing, the grinding, the sieving of the seashell, the sieving of the EPL, then producing the EPL aggregate to be used in the study. The following substitution level is going to be used with respect to the methodological approach. The 0 to 50% is going to be used with respect to the substitution level of both materials. A water cement ratio of 0.45 is going to be maintained throughout the mix using a prismatic sample mode of 40 by 40 of 160 according to the Brazilian standard. And the curing is going to be done as specified by the Brazilian standard. With respect to the various tests, the tests to be performed with respect to the fresh test, the consistency index test, the specific gravity test, the density test, the thermal conductivity test, the apparent density, the open porosity, the water assumption, the procedural strength, the compressive strength, the fire resistance test, then acoustic test, to test the response of this material with respect to fire and with respect to sound as an insulation material. On the aspect of the statistical analysis, a linear regression approach is going to be used, taking the relationship between density and thermal conductivity, and also the percentage of substitution of each of these materials with respect to the thermal conductivity of this material. In R-square is going to be used with respect to this, and origin probe total version is going to be used with respect to the statistical approach. On the aspect of the impact environmental life cycle assessment, a system boundary of cradle to gate is going to be used as a system boundary in the life cycle assessment approach. The production, the transportation, and the distribution state, those are the phases of life cycle that is going to be considered. While on the aspect of the impact category, the global warming potential and the embodied energy in producing these materials is going to be taken into consideration. While on the aspect of the hydrothermal test, the methodology specified by Benzema is going to explore to check the environmental impact, to check the effect of moisture with respect to these materials, how it's going to be react, and also the Wi-Fi Plus software is a software that aids in also evaluating the hydrothermal effect and also checking in terms of the electrical consumption of this, because it has a multifunction purpose. Checking the hydrothermal effect and also the electrical usage of these buildings to check how it's going to react when using these materials. Based on the partial results being obtained, a kinetic result was obtained. Based on the kinetic results, the EPL motor tends to demonstrate a coarse-like behavior, because it tends to demonstrate a coarse-like behavior, as clearly seen from the graph here, compared to the seashell motor and the fine aggregate, compared to the seashell aggregate and the fine aggregate. It tends to demonstrate that coarse-like behavior of an aggregate, but as a percentage, as the strip sizes tend to decrease, it tends to attain a fine aggregate properties. But the volume, the percentage of retention of this material tends to diminish compared to other materials, but it tends to behave like a fine aggregate as a percentage of sieves. As it begins to pass through the various strip sizes, it tends to attain that fine aggregate property compared to the rest materials, compared to seashell aggregates and fine aggregates. One of the aspects of the consistency index test, the consistency, as the substitution of this material tends to increase, the workability of this material tends to increase also. The workability of 24.3 cm was attained based on the 40 seashell EPS, and sound substitution was attained on the 40% substitution level. But however, none of the tests conform to the Brazilian standard. But the 40% substitution rate somewhat attain closer value with that of the Brazilian standard, which specifies 25.5 cm to 26.5 cm, attaining the value of 24 cm as a workability level, attaining a value of 24.3 cm, which tends to come somewhat closer. But adjusting the water cement ratio of this material and also optimizing the mix, which this research tends to explore, I think that adjusting it and optimizing the mix, this value definitely, the substitution level tends to increase. The consistency level to come up closer or achieve the value being specified by the Brazilian standard. On the aspect of the compressive strength, as the substitution level increases, the compressive strength decreases. However, this is a compressive strength of a 7-day result. Based on the standard specified by the Brazilian standard, based on the standard specified, all of the substitution level attain the value superseding that of the standard being specified, which the standard specified a 2 megapascal, but all of the sample attain a value superior than what the standard even specified, to show that yes, this material also can be used in form of the structure. It can be used as a structural material also, and also can be used as a non-structural materials based on the value being attained here beyond the normal standard as specified. One of the aspects of the flexural strength, as the substitution also increases, the flexural strength tends to decrease. But this material tends to demonstrate a crack-resistant property, whereby it tends to resist crack. It tends to resist crack, as well as it claims to resist crack which shows that using this material in a load-bearing application or in an external wall, it tends to resist any effect, either horizontal or vertical, or vertical direction of forces. It tends to resist it based on the resistive property which it tends to display here. Based on this, an experimental application of this material was done to show if this material can be used, if it can be used as an insulation motor, if it can be applied as an insulation motor without any segregation from the actual motor, using the highest percentage, which is 50% percentage of the substitution level for both materials. It clearly shown that yes, this material has a property to adhere to the wall without any segregation between the wall and the materials, as clearly seen here. However, some little bit of dots, some little bit of the EPA traces was still noticed. However, the finishing of this material required an adjustment in the water cement ratio to be able to balance the property of this aspect. The research is being aligned based on the following step. The following steps are meant to be done, which is the writing and submitting the 2 articles, that which has already been done, the conclusion of the characterization of materials, which is yet to be done, the production of more samples with respect to the period of 28 days, which is yet to be done, the testing, more testing with respect to the fresh states, more testing also with respect to the hardened states, and more testing, more statistical analysis, which is yet to be done, evaluation of the life cycle assessment, which is yet to be done, testing of simulation of hydrothermal, simulation is yet to be done, the writing and conclusion of the dissertation, and the defense of the dissertation, which is yet to be done, which is scheduled to conclude in 2026 February. The final consideration of this material, it clearly shows that as the substitution of this material tends to increase, the thermal conductivity of this material also tends to decrease, which is vice versa. The density decreases, the thermal conductivity of this material decreases as the substitution of this material tends to increase, as well as seen in the literature, The next, as the workability of these materials, also tend to increase as the substitution of these materials, as the substitution level tends to increase, which is clearly seen in the literature and also in the experimental results being obtained. Also, it is also necessary also to optimize the combination of these materials so as to balance the individual property with respect to the thermal insulation aspect and also with respect to the structural aspect of this material, so as to minimize the level of crack when used to minimize the level of crack. Also, in order to better the energy situations of this building. Also, as the density of this material tends to decrease, it tends also to promote the thermal conductivity of these materials. So diminishing the density also diminishes the thermal conductivity in the same way, decreasing the thermal conductivity in the same way, making them more conducive and more better thermal insulation materials. The next, as the substitution of this material increases, the compressive strength of this material also decreases. Likewise, the flexural strength of this material tends to decrease. In conclusion, the use of both materials also shows a good aspect that yes, these materials can be explored, can be used as a thermal insulation material, in the same way promoting circular economy, producing a cost-effective, energy-efficient materials, and also producing a material that is more conducive for social housing or low-income housing projects. These are the references with respect to this proposal. Thank you very much for your attention.
Thank you, Luka. I think you went fast. Luka is from Nigeria, so it's a GCUB student. He's here right now since I think April of 2024. So I'm very glad that he's here. I think we learned a lot. And last time we met, he made some food from Nigeria for us. Next time, we will have to make some Brazilian food for him. He worked very hard. So, Luka, my dear, thank you so much for presentation. You kept in the time slot, but next time I won't tell you so much about the time. I'll let you speak a little slower because for us it was a little too fast. But I'll give the word to our external examiner, my evaluator, Professor Sérgio Pérez. The word is yours. Thank you.
Okay, thank you, Luca. You see, it's not easy to understand your English because you're not used to that accent, but so that's why you need to speak slower. Okay, but don't worry. You see,
Professor Sérgio, sua voz está bem baixinha. Tem como aumentar um pouco?
I don't know what happened. I need to buy another. Is it better now?
No, it's very far. It's like your voice is coming very far, from very far.
Let me see. Yeah, and now it's better.
For me, it's not, but for others, the others, can you hear well, Dr. Sérgio Pérez? Everybody?
You see, I'm screaming.
Now.
You see,
Now it got a little better.
All right, I'm gonna buy a new microphone, because this one here, you see, sometimes works fine, sometimes doesn't. So I don't know what happens, but anyway, I'm gonna buy another one. But
Okay.
let me explain. I'm gonna make some comments. You see, first of all, you see, this one here is not a proposal of utilization of styrofoam. You see, you're testing the styrofoam. So I think, but in here you say isolation, but it be thermal isolation, right? Or water isolation, because we have so many types of isolation that we have to be more specific. You see, so you need to talk to your advisor in order to verify what is the best title for your dissertation. Okay? And well, I'll give you like some issues, like aesthetical issues, and I'll leave my material in Emilia's pigeon box tonight. All right, when I go to university, so in that way you can go and verify everything with you. All right, and let me explain something. When you talk about introduction, you see on page 9, you see you were talking about literature that was based in 2010. You see, it's estimating that 199.5 billion people live in slums in Africa. You see, and this one here is kind of old. That's 15 years ago. So you need to get data more updated. All right. And I'm gonna give you like some material, or I'll ask Amelia. I'm gonna explain to her when I meet her, and say that, you see, because you're talking about thermal insulation, you're talking about heating, you're talking about cooling. You see, I want to find out if you have this problem of low temperature in your country. All right, because as far as we know, here in Recife, you suffer because of the hot weather that you have here. You see, you have to verify what will be your focus. You see, because either be cooling or both of them in how it works. And also, when you talk about, you see, in here on page 9, you see, nowadays the buildings they contribute with like 56.7 of the carbon dioxide emissions. I want to find out if this value is true because we never heard about only buildings. That would be more like transportation and residues. That would be the sectors that most contribute with the greenhouse gases. And they put here that would be buildings. I want to find out where to get this information from. You can answer me, by the way.
Professor, can I answer you?
I'm saying that in here say that nowadays the buildings they contribute with 56.7 of the total like greenhouse gas emissions. I want to find out where to get this value from because it's not even mentioned. See, most of them would be more in the transport section and also in the like residues sector. That would be the where you obtain the highest greenhouse gases emissions. So I want to find out where to get this value from.
Okay, Professor.
Did you understand me?
Yes, Professor, I understand you, Professor. The value is gotten from an article which I use in writing the proposal.
Show the slide, Luka, that you showed that, so we can see exactly if it's energy consumption, emissions. Okay, so like what Professor Sergio, which works with that, says is that what literature has shown is residues and another element there, transportation contribute a lot. So we want to know exactly what was he based on when he did this calculation. Do you remember?
Okay. Yes, Professor. The calculation was based on preparing like a thermal insulation material using like EPS. So he discovered that yes, this building contributes about this percentage with respect to the energy consumption. This is the amount of emission being produced with respect to this.
Yeah, I want to, well, afterwards we'll check that, because I think that'd be like either too high for that, so otherwise that would be one of the main goals, right, in the ODS to verify that. You see, another thing that you're talking here, you see, you're talking about conventional isolated material, and you use a reference from 1964. You see, you and Amelia, the only person that was alive was me. All right, the other one, you are so young that you see. Can you check this one? You see, because in 1964, I think that's a too old reference.
Qual a página, professor Sérgio? Desculpa.
Page 10.
Page 10.
You got here. You see, the reference is 1964.
Al-Shawake, né?
Yeah. See, that's
Certo.
too old. I would say that everything has like improved. Anyway, let me go. Well, it's gonna take long if I gonna go over all your work, but I will meet you and Amelia and show all the points that I want to make. You see, and let me see. You see, when you justify your study, and here says you're talking about the social buildings that we have in the Pilar in Recife, all right? But you did not mention the problem that we have the Ilha de Deus with the seashells. And I think that have to include that because they are not discard the seashells in landfills, they just put in the river delta, and this one here is cause a lot of problems for the population. Let me see again. By the way, when you talk about the objectives of your research, you see putting here like the specific objectives. You're putting here to evaluate the physical and mechanical properties of motor, a different percentage of styrofoam and Sudoro shells, all right, and substitution. Why you're using 20 to 50%? Why don't you use like, because that's something that you're going to investigate, right? Because the more you use, the better for the environment. And also, let me explain something. When in the end, when you put like SSE 30, you should express the percentage of Sudoro shells and the styrofoam that you're using in each mixture, because you put like 30%, 20%, but you have to verify here what would be the percentage of each component, because you can use like 20%, 10% Sudoro shells, 10% styrofoam, all right, and then you can put like 5%, 50%, so it'd be completely different. So you have to specify what are you using, which percentage you're using in all of them. Okay, let me see something. Emilia, so that's the questions that's for you. Do you need to know the process of selecting the literature? You see all these kind of flow chart, is it necessary?
Ele usou a revisão sistemática da literatura. Você está dizendo que ele não precisava usar, era? Eu não entendi.
You don't need to show how many, otherwise it'll be like, it'll take too long for you to go and check the articles, because this one here is be just like internet search, right? Or
Não, ele fez uma análise sistemática da literatura. Ele usou o protocolo de pesquisa, né? Usou 3 bases de dados e chegou a 64 artigos, se eu não me engano. Eu não sei porque ele não referenciou todos. Mas isso a gente tem usado para fazer os artigos, né? Que vão embasar, porque ele só vai poder defender se ele tiver um artigo publicado. Então a gente. Tá com um chiado, professor. Não sei se eu tá conseguindo me ouvir.
Não, tô lhe ouvindo bem.
Pronto. Aí, essa é uma estratégia que a gente tem usado de ter um artigo de revisão sistemática sobre o tema com as perguntas da pesquisa que vão embasar, né, o desenvolvimento da pesquisa dele. Então, por exemplo, as porcentagens de mistura, ele provavelmente conseguiu na literatura. Ele perguntou quais são as misturas, quais as porcentagens usadas, para que é usado, para ele justificar, de certa forma, a pesquisa dele. Para ele chegar de 10 ou de 20 a 50, provavelmente ele encontrou na literatura que eles deram os melhores resultados. Entendeu?
Mas ele está diferenciando o que é Sudoro e o que é o EPS. Ele tem que chegar e está colocando 30% da mistura.
Sim, eu entendi isso, professor. Eu concordo com o senhor. Eu acho que ele pegou em pesos iguais, mas ele vai poder explicar. O que eu estou dizendo é... Eu pensei que o senhor estava perguntando sobre a revisão sistemática. Por que ele fez? Não.
Não é porque ele fez, é porque ele coloca isso aí para poder chegar e colocar aqui na revisão da literatura, colocar como ele fez isso aí, certo?
É porque a metodologia PRISMA, que é o Preferred Reporting System for Meta-Analysis, for Systematic Review Meta-Analysis, ele fala exatamente como é que é o procedimento. Ele tem que seguir passo a passo aquele protocolo do PRISMA. Eu acho que é assim que ele seguiu. Aí tem que dizer quais são os critérios de inclusão, quais são os critérios de exclusão, para que qualquer outra pessoa que queira refazer consiga entender como é que foi o processo, sabe? A metodologia que ele acabou usando foi essa, do Prisma. Eu acho, não sei se ele explicou direitinho. Se não explicou, tem que explicar.
E aqui botou literatura cinzenta.
É.
Isso.
Luca, explica aí. Primeiro explica about the proportions of the two materials, because you talk about 20% substitution. What's the proportion of each material? And talk about the gray literature. How Professor wants to know.
Okay, so with respect to the substitution level of both materials, both substitution level were adopted from the literatures. Most of the literatures use that aspect, which is the literature I consulted use the aspect 20 to most of the literature focus on 10 to 50%. So that is what most of the literature focuses on. So I adopted that substitution level based on the literature. With respect to the gray literatures were being adopted. Like consulting each of these articles, I'll go through the references. Anyone I find out somehow correlate with what I'm doing, it also undergo the same process, the inclusion process, in respect to this first selection process on the systematic literature review.
But Luca, he's asking what's the proportion between EPA and EPS and the Sururu shell. When you say 20%, he doesn't know what's the proportion of each one.
Okay, in respect to the proportion, I use a 1:1 percentage, which is I want more EPL, more C shell. 1:1 percentage of both materials.
Half.
1:1. If I'm using 50% C shell, I'm using 50% expandable polystyrene. Likewise, 1:1.
In grams, yeah, in mass, because you are not substituting volume, but in mass, yeah.
Yes, Professor, in mass, not in volume.
Yeah, you have to put that information. All right, you need to put this information and why you use the same proportion in mass for each one. You see, also, you see in page 18, you see Milling, Marshall, and Martin, they use EPS as a partial substitute for cement, and they dissolve it in acetone. You see, I want to find out because I have to make like a survey here, say the acetone can cause damage to the concrete, the non-cured concrete, and also they can dissolve like composites that would accelerate the concrete and also can cause a microfracture. So you see, I want to find out, are you going to use this like acetone?
No, Professor, I'm not using acetone. It's just Portland cement. The CP2 is 32Z.
Ele não está substituindo cimento, professor, ele está substituindo só areia mesmo, e não vai usar acetona para diluir ele, não.
All right. You see on table 4, page 20, you're using here density, right? So this one here is combined the density of EPS or EPS minus mortar. Right, and also the composition of the material, I think that should be in the first column, so you would know what kind of material be that. Then you have density, conductivity, and so on. Let's see, it has to be more logical. Instead of put the composition in, like in the very last column before the authors, you can put the first one, and then you can put density, conductivity, because all of them be related to the composition of the material that you have used. Okay?
So
that's my opinion. So you have to check with the media anyway, because the composition that's of the material, that's what is going to give you like the density.
E a proporção também.
Yes, the proportion as well. You see, and do you understand, Luca? No, you see, I'll give you that to Amelia anyway. Tonight I'm gonna give her.
Okay.
So you can check, you know, one by one the comments that I'm making. You see, and also in here, figure 2 on page 21, you put relationship between density and water absorption. You see, as a physical property of styrofoam or the EPS, right? In here, put like you see, you mentioned the authors, but you need to find out the value. So it's kind of complicated for us to understand because you don't have the proportion of each one. So I think that it has to be to clarify that. You see, the same thing happens in the on figure. Let me see if I'm saying here. On figure 4, you see, and also you see what is the result of the particle size that we're using these studies. You see, what's the result, what the conclusion could you make, you see, because they are using different kind of particle sizes and different kind of material. You see, we put it here in soil, in concrete, in mortar, and gypsum, and then I want to find out what is related to your research. Okay. Again, you see on page 24, you see you mentioned the authors of the articles, but we don't know the composition of each one. When you're talking here density, that is 0. The thermal conductivity, it varies from almost 0.25 to 0.55. So this one here will be what? 0 density will be what? On page 24.
You want to answer, Luka, something?
Yes, Professor. I'm going through it now. Page 24. Yes, Professor. Page 24, Professor. Professor, are you making reference to the figure?
Quer falar em português, Sérgio? De novo?
Por que densidade 0? E que material é esse que está falando aqui?
You said about density being from 0 to 3 or some zeros to somewhere, and how can it be 0? He's asking.
Por favor, qual é a página?
24.
24.
I think it's the data from Roma.
Professor, what I have here is a relationship between density and compressive strength. I don't know if that one, what this professor is referring
Conductivity, thermic conductivity, and density. Page 24. It's figure 4.
Okay, figure 4, density and thermal conductivity. Yes, Professor.
He's asking how can density 0?
Okay, this the essence of is my graphical representation. Density is not 0, it's a graph. I start from 0, the origin, which is from 0, progress. The 0 is the origin of the graph. That's where I started from.
No, but he put like Homer and all 2022 input as it was their data. You understand that? That's why I could not understand.
I'll need to work on the graph. That's 0 is the origin, professor.
Esse deve ser um erro, viu, professor? Na hora que ele foi grafar esse negócio, eu acho.
Tá bom. Emília, depois eu converso com você sobre,
Tá certo.
sobre isso, tá? You see, in here, the same thing that you're talking about on the mechanical properties of EPS, and then it has here linear relationship between compression and density, but you don't know the composition of the materials that are in the figure, all right, in the graph. So I could not understand, you see, how they have so different densities, all right? So in that way, you need to know which is the composition of each data, okay? And here on page 28, you said at the end of the first paragraph, you put here that you have used particles of the mycelium shell that varied from 0 to 0.4. So 0 is no use, or you have used like very tiny powder. I do not understand this one as well, because 0 is you cannot have. Should be 0 point something, or 0 you won't have it. Okay. You see on page 29, when you put here a graph of the composition of seashells, and in studies related to mortar applications. You see, for me, you are talking about calcium carbonate, all right? And so that's fine, but the other one would be just traces of the other material, you know, alumina, ferric oxide, all of them would be very, very tiny. And then we're talking about changes in variation, you know, 200%, you know, and it's very tiny portion. And I think that you should concentrate more on the calcium carbonate. And the other one would be like traces, and you have to verify which, if these components, they have like influence in the mixture that you're making. You see, let me see. You see, Emilia, again on page 32, you go and have 0 density. And these they are data from Carolina Martinez Garcia et al. Talking about muscle shells. All right. So that's why it's kind of confusing. You see?
Espero que o professor Vitor possa nos ajudar nessas coisas.
All right. And when you're talking about different kind of shells like Vieiras, Boisri, and other kind of shells on page 34, I think that it would be necessary to put the difference in the chemical composition and what would be like the percentage of calcium carbonate. All right. You see, and again, on figure 6, the data from Safi and El Medeli, is different from 0, but you have to verify, you see, in the compression resistance and flexion, but you need to find out. You see, I'm kind of confused anyway on this. You see, on page 35, you see, you have to have like a glossary of all the symbols that he's using. You see, because like they put here on page 35, the tipos de aglutinante, ok? W por si, o que significa isso?
Water, concrete. A razão, água, cimento, eu acho. Water, é porque para fazer concreto ele é muito comum, essa razão, água, cimento, sabe?
Então tem que botar aí embaixo o que é cada um.
Mas fazer a lista, talvez, de símbolos e... Então, no caso, é nem símbolos, é de... Tem outro nome. Lista de siglas, talvez, sei lá.
Tem um glossário que eu tenho que colocar. Ou símbolos, ou alguma coisa dessa. Tá? Certo? Aí, quando ele fala das correlações da 37, aí eu fico na dúvida em relação ao... Ele bota aqui os autores, mas a gente fica sem saber quais são as relações que ele usou, tá, do EPS com o Seychelles, se estava sem um, sem outro, para poder verificar. Na página 38, eu fui ver aqui a densidade do cimento, ele é de 3,1 a 3,2 toneladas por metro cúbico, certo? A do concreto 2,2, mas aí depois, quando vai falar sobre a cortiça já é uma densidade bem baixa. Então, quando ele fala sobre as densidades, certo? A cortiça é bem baixa. Aí eu observei também o seguinte, que quando ele vai na página 42, tem um gráfico aqui, matéria de isolamento, ele colocou o XPS como sendo 0,8, e eu vi na literatura que é 0,03 watt por metro Kelvin, certo? Aí quando ele coloca aqui a cortiça ela é, cadê aqui? A cortiça natural expandida 0,037 a 0,045. Então, esse gráfico aqui, como ele botou essas duas unidades, esses dois aqui, XPS e a cortiça grande, agora ele falou aqui, agora está colocando aqui argamassa de cortiça, argamassa disso aqui. Sem a gente saber o percentual, fica difícil a gente chegar e saber esse coeficiente de isolamento. Tá entendendo?
Eu entendo, professor. Eu acho que... Eu entendo, mas eu acho que ele vai ter que criar umas tabelas relacionais. Talvez ele vai falar que Gomes et al. Fez esse tipo de teste e conseguiu isso. Aí, quando a gente quiser, já é para Gomes et al. Para ver qual é a proporção dele, entendeu? Tem a tabela com as proporções. Eu acho que talvez no início ele tinha isso. E aí ele vai voltando para esses dados. E aí ele faz essas análises de meta-análises dos dados com aqueles gráficos, entende? E eu acho que no início ele precisa clarificar, né, como foi usado essa mistura. Mas, assim, a referência é Gomes, né? Se tiver alguma coisa aí, Gomes deve ter explicado como é que ele fez a condutividade térmica, essas coisas, né?
Está aqui, é elaborado pelo autor aqui na figura 9, certo? Aí Ele não coloca aqui, ó, a cortiça pura, o EPS, o XPS.
Não, é a mistura, é a argamassa que tem uma mistura de porcentagem, provavelmente entre 10% e 50% de cortiça.
Mas ele precisa colocar isso, mas precisa colocar esses materiais sozinhos, como ele botou lã de vidro, cânhamo,
Sim.
isso aí, certo? Porque são coisas...
Eu acho que ele tem uma tabelinha, professor. Aquela é um gráfico que ele fez, que tá com amarelinho e negócio. Acho que tá em algum lugar antes ou depois aqui. Deixa eu ver. É, página 42. O senhor tá vendo a 42?
Tô vendo a 42.
Figura 9. Eu acho que ele tentou fazer isso. Foi pegando individualmente os materiais e falou qual é a condutividade térmica de cada um em isolamento. E depois as argamassas, quando ele faz.
Mas ele não botou sozinho o XPS e a cortiça sozinho. Que tem que
certo.
Para poder verificar aqui na argamassa o valor é tanto e depois, quando faz a proporção, atinge isso aqui. Para poder a gente chegar e se orientar.
Entendi. Então, faltou a cortiça, né, que o senhor disse, o XPS e o EPS também, não é isso?
Exato.
Oh, do you understand, Luka, what Professor Sérgio is saying? Can you hear him?
Professor, I can hardly hear Professor, but I really get all what he's saying.
I'm guessing, I'm telling you, like he says that you put the materials separate and compare them with the argamassa, okay, with the mixture.
Okay,
and he's
Professor.
saying that in these materials isolated, you should put also the concha itself, the XPX, the cortiça, EPS alone also, the material itself, not argamassa, because when you do argamassa, it changes.
Okay,
Yeah?
Professor.
So he can compare individually and then in the argamassa, no?
Yeah, and
Okay, Professor, I understand.
He needs to put the amount of XPS
on the argamassa.
Yes, on the argamassa, otherwise they won't make sense to us.
Yeah. So and for each, I think in one place you have to include wherever you talk about argamassa XPS, you're using reference of X, which uses this percentage of substitutions to get these values, you know, because it says it might change a lot. Argamassa with 10%, 20%, 30%, 40%, 50%. We don't know if you're doing the average. What is the percentage? So like at least a relation between this has to be put somewhere so we can understand clearly what is the proportion in each one of these things. That's what I understood. Se tiver errado, fale.
Não,
professor.
Tá certo, Emília. Olha, e depois na página 52, quando ele bota aqui SS é 20, SS 30, SS 40, SS 50, se, era bom se ele chegasse, se fosse 50%, 50%, mas aí ele coloca o SS, no caso 20, 10, o E 10, que a gente sabe que está com 20%, é 10 e 10 de cada um.
Entendi.
Aí você separa, você sabe que tem Sulu Shells e sabe também o que é IPX, tá? Porque por aqui a gente não consegue identificar a proporção de cada um aí. E essa proporção, ele até pode variar também, né? Logicamente que talvez o mestrado não dê tempo, mas para isso aí seria bom para poder até a publicação, eles vão pedir isso, tá? Qual é a proporção de cada um deles. Bom, fora isso, eu vejo que é muito trabalho que tem que ser feito, certo? Só precisa organizar um pouco esses dados que ele já obteve, certo? E eu não tenho dúvida que com a sua orientação de Maria Helena e de Mahmoud, ele vai ser successful. But he needs, you know, you see, I can guarantee that under supervision in Maria Helena and Mahmoud, Luka will be successful, you know, in complete his thesis. It's a lot of work because he has a lot of experiments to make, all right? So sometimes it's necessary only to justify because they put 20 to 50% total, all right? But he needs to find out, he needs to inform why he's using this percentage and the amount of seashells and the EPS that you see, if this material will be available in here, you see, if he wants to use that back in Nigeria, you see, what kind of temperature you see is he's gonna face in Nigeria, or if this one here is just to finish or be focusing in his Pernambuco, all right? So you have to delimitate his area of study, because you cannot go and use his finding everywhere in the world. So he needs to be more specific, you see, for his sake, all right?
Yes,
So
yes.
I'm going to stay here forever.
Thank you so much,
All right,
Professor
thank you
Sérgio.
for inviting me, and sorry for taking so long for me to,
No, it was perfect.
to make my comments.
Thank you so much, Professor Sérgio. I think everything is very well put, and sometimes like some stuff is clear for us because it's construction, but it's very important, this view, the external view, you know, Luca. And like
Thank you, sir.
your area actually uses so many elements. I mean, you're very courageous, I have to tell you. And I should know that because you left your country to come here to study and do your master's without knowing anything, knowing the language, doing nothing. So I should know by nature that you're very courageous. So you are. And I think you're also courageous because we allowed and went after the best professors to be advising you and helping you to develop this. So we're not shy on looking for criticisms to improve. But I'm going to pass the word right now to Professor Vito, because I'm sure he's going to bring his expertise about materials in construction. I think will help us. Then we'll get out a little bit and talk a little bit. But I think from now on, you, Mahmoud, and Maria Elena and I should meet at least once every other week to see the results a little bit closer and see the test you're doing, what you're doing, so we can really finish. It's a lot of work, as I understand what Professor Sérgio said. So I'll pass the word right now to Vito. Vito, querido, obrigada por ter vindo, viu?
Okay, I thank for the words, Professor Emilia, and I greet all the committee, Professor Sérgio Pérez, Professor Mahmoud, and the candidate Luka, and the master's students that they are watching us. Okay, Luka, so
Thank you,
I
sir.
will start with two major concerns about your qualification, about the document that you deliver me. And the first comment is about I think Professor Sérgio Pérez talked about it, but I'd like to reinforce his words, because there's a lack of information about the mixed proportioning of the materials. Okay, you don't make clear the content of APS and Sururu shell. Okay, so you just said that it's half-half, okay? But you must leave it clear in the text. Okay, and also you must construct or build a table and summarize the contents of cement, of EPS, of sand, and Suru shell, water. Okay, so the proportion of the materials also must be clear in the text, and you must present these proportions. Obviously, when you publish and submit this work to publication, and the reviewers will ask about that, okay? And in the materials and methods section, I have all the consideration about the reference mixtures and the mixtures that you choosing to prepare, because the reference mixture that you choose has a water cement ratio of 0.48. Okay, but this mixture, this mortar, is a mortar for the compressive strength test of cement. Okay, and your work is focused on a lightweight mortar. Okay, so insulation mortar is a type of lightweight mortar. You use pseudo shell and EPS, and both can be considered as a lightweight aggregate. So you can't compare a mortar, a conventional mortar with high compressive strength reach above 30 MPa, okay? You can't compare it with a lightweight mortar, because lightweight mortar, the compressive strength comes about 3 or 5 MPa, because they have a high porosity, a lower density, and the compressive strength values are very low. Okay, so you must choose another reference mixture. You can still with this data, okay, for this data can aggregate in your work, but I recommend to choose another reference mixture with only cement, water, and EPS, and then you make the replacement, replacing the EPS by pseudo shell. Okay, because you are replacing pseudo shell, or you are replacing sand by pseudo shell and EPS. Okay, but as I stated previously, sand is a conventional aggregate, and pseudo shell and EPS are lightweight concrete. Okay, but you are use the powder of pseudo shell. Okay, the powder. If you are the powder, okay, it can be considered as a conventional aggregate. But you must choose the reference aggregate. The reference mixture must be a lightweight mortar, okay, not a conventional mortar. Okay, so you can compare. And also the mixture, they have a problem because the compressive strength of the mixtures are very high. Okay, so you reach about 15 MPa, and these values are very high for lightweight concrete, lightweight mortar. And so you must revise these proportions. Okay, probably as I noted here, your water binder ratio is very low. It must increase. It can be about 0.60 or 55, 60. It's around these values. Okay, and it must be the proportion of EPS of cement. So the porosity will increase, the density will decrease, and you reach the values that are in the literature. Okay. Also, the most important for me, the most important test for lightweight mortar is density. Okay, not only compressive strength, but density. And you must, to carry out this test, observe that you haven't so far performed this test. Okay. So after these major considerations, okay, I have minor considerations, but I have a lot of annotations in written version of your work, so I can deliver you back afterwards. The version is all crossed out. So if you have some question, you can contact me by mail, by WhatsApp, okay? But there are some mistakes of grammar I have noted. And just like Professor Sérgio Pérez stated, the graphics are kind of messy, okay? And are confusing. And some data with 0 of density, and it's impossible. Some works are not in the reference section. Okay, I searched for this some works that are cited in the text, but they are not in the reference section. For instance, they are figuring. I can tell you after, but I have highlighted in the text the works that are not referenced. Okay.
Sure.
And you must improve the quality of the presentation of the graphics. For instance, figure 2 in page 21. I think for example, we could use the same color of the dots. Okay, so use colors different for the dots and for the lines, and this confused me. Some data are wrong when the axis of density, for example, you must multiplicar por 100, the values for 100, because the densities are in kilogram per cubic meter, but are very low. Okay, so you must do como é multiplicar em inglês, Emília?
Professor, tá certo. Entender todas as
Multiply. Eu estava falando, só que estava sem som, desculpa. Multiply by 100.
Multiply by 100, okay? And, for example, figure 3, since I didn't understand this figure, I think you can improve the presentation, okay?
Okay, professor.
Figure 4 is stated you have 2 axes, but you didn't specify the samples that are in primary axis and the secondary axis. I know that calcium carbonate is in the secondary axis, but you must make it clear in the text, okay? Figure 4. Okay. And some figures, the number of the figures are wrong. Okay, but I made this, I highlighted this in the text. Okay, in figure 10, you put here some abbreviations, some acronyms, but you haven't cited this previously in the text. Okay, figure 10, page 44. Okay, but you are inserting an abbreviation for the first time. You must explain before what they mean, okay? Also, I'm afraid about you stating the text that you will perform a life cycle analysis, LCA. I know it will demand a lot of effort to do, because you must track the carbon footprint of all of materials. Okay, so there is a lot of things to do, a lot of work that you must the remaining time. So perhaps you must talk with your advisors to choose the best task to do, because maybe it will not possible to do everything that you are planning. Okay. Okay.
Tá
Yes,
bom.
professor.
And also about a formatação, Emília, aqui no final, né?
Não, todo texto tem vários problemas.
Ok. Então tem que melhorar também a formatação aqui no final, as referências, né? Tá tudo sem a formatação da BNT. Tá? E, bom, acho que eu concluo aqui. I finish my words. There are a lot of comments to do, but we can talk afterwards, okay, Luka, about that. I just made my main comments here to save time from everyone. Okay, so
Thank you so much. Go ahead. Desculpa, Vitor.
now I pass the word for Professor Emilia now.
Thank you so much, Vito. Thank you so much, everyone. We're gonna go a little bit outside. We're gonna create another room so I can talk with Mahmoud if he's still here, and Maria Helena, Vito, and Sergio Perez to see what should be the next step for this qualifier. Okay, so just wait a little bit. We'll get out. We can turn off our sound. Hi, Luka. Hi, everyone. We are happy to inform you, Luka, that although you have a lot of work, a lot of suggestions, but most of all, that we need to make a more clear plan of work together. And I understand that's a little bit our fault too, because we were not able to meet the three of us, the four of us together. So we already set up for our next meeting on the 9th, Tuesday at 1:30. Okay, Maria Elena can just stay till 2 p.m. but me and Mahmoud can stay till 2:30. We'll start a plan, organize. We'll shrink a little bit our objectives, and also do a more scientific justification of the choices of the materials, percentages, and reorganize a little bit the datas. So it says, like one thing that they mention in this evaluation is, let's not do tests or graphical analysis just for the sake of doing. It has to have a meaning and a justification. So like we need to put 2 steps back so we can go forward on the process. Okay, Luka? But I want really to thank and say that your banca, your evaluation team, had confidence in you that you could do the changes in these 6 months. So I want to thank especially Professor Sergio and Professor Vito. Both of them said that you are approved for qualifiers, although we have lots of change, but because they trusted us to actually now work hard, and they also put themselves in this position to help us if you need. Okay, so I'll let you talk a little bit, and if anybody wants to talk.
Ok, professor, muito obrigado por toda essa oportunidade. A apresentação essas propostas. Muito felicidade. I'm very happy for the opportunity you guys have bestowed upon me to be able to take upon this challenge. I know it's a challenge, and that's why I choose to go this pathway, to be able to challenge myself more, to be able to cut across more disciplines. And also, thank you guys very much for your positive comment, for your positive criticism, which I truly need to move this research more forward. Thank you very much, all of them.
Obrigada, Luka. And Professor Sergio is going to live in my box at the teacher's place. Vito, you can ask him and talk to him. And I also have some comments about the formatting, so also schedule some meeting from now to next week so I can pass my suggestions. And on the 9th, we'll be together. And from then on, we'll set a more structured regiment of meetings so we can do it faster and with more supervision. Okay?
Okay, professor. Muito obrigado, professores.
Thank you. Anybody else want to say something? Do you want to stop the presentation so we can take a picture of everyone?
Sim, professor.
Okay, everybody, if anybody wants to come in so we can show your faces. Hello to everyone.
Here.
Yeah, Mahmoud, I don't think he knew how to get back in. But anyways, let's take a picture anyways. Oh, wait. Okay, 1, 2, 3, and now. Okay, thank you guys.
All right.
And I'll send you the video so you can watch Luka.
Okay,
all right. I'm going to put in your pigeon box.
Thank you.
All right.
Thank you so much. Bye.
Tchau, vocês aí.
Next Thursday is Jalisson. Bye. Bye. Tchau, Vitor. Obrigada, viu?
Tchau, professora. Vou deixar na secretaria, tá?
Muito obrigada. Muito obrigada.